Hello, welcome to our online class. My name is Kemuel J. Cardona, your presenter. Before we begin with our topic, let us have a short review. Last time, we talked about conic section. Conic section is a curve obtained as an intersection of a plane, called the cutting plane, with the surface of a double cone. We have discussed the types of conic sections. They are parabola, circle, and ellipse. This figure is an example of parabola. This one is a circle. This is an ellipse. And this figure is an example of hyperbola. In this lesson, we will focus on hyperbola. These are our objectives. Number 1, locate hyperbola's vertices, center, foci, co-vertices, and asymptotes. Number 2, write an equation of hyperbolas in standard form. Number 3, graph hyperbolas centered at the origin. Number 4, graph hyperbolas not centered at the origin. And number 5, solve applied problems involving hyperbolas. This is the definition of a hyperbola. Hyperbola is one of the types of conic sections formed by the intersection of a plane perpendicular to the bases of a double cone. Note, we will limit our discussion to hyperbolas that are positioned vertically or horizontally in the coordinate plane. The axis will lie on the axis or be parallel to x-axis and y-axis. We will consider two cases, those that are centered to the origin and those that are centered not in the origin. Here is a video that shows several possibilities for forming a hyperbola by intersecting a plane and a double cone. As you can see, the black color is a plane and it is intersected to a double cone and a hyperbola is being formed. Concept of a hyperbola. A hyperbola looks like two mirrored parabolas with two halves being called branches. Like an ellipse, a hyperbola has two foci and two vertices. And like an ellipse, the foci in the hyperbola are farther from the hyperbola center than its vertices. A hyperbola is a set of all points, P, X and Y, such that the difference of the distance from P to 2 point, called foci, is constant, where the absolute value of distance 2 minus distance 1 equals 2a. Now, parts of the hyperbola, we have the center. Center of the hyperbola is where the line segment connected to the vertices passes through. Vertices of the hyperbola are lying on the branches. If this is the branches, then these are your vertices. Foci are inside the branches, these 2 points. Transverse axis is a line segment from the vertex through the center and ended to the other vertex, which the length is equals to 2a, this line. Conjugate axis is a line segment perpendicular to transverse axis and has the co-vertices and its endpoints. And the line of this is equals to 2b. If this is the co-vertices, this is the conjugate axis. Asymptotes are straight lines that form an X that approaches to the hyperbola or branches but never touches these two lines. Key equation of the hyperbola. For letter A, we have an equation x squared over a squared minus y squared over b squared equals 1. The center of the hyperbola is at the origin. Since the value of h and k were not given, then the transverse axis is on x-axis since the variable on top of a is x. For letter D, we have an equation y squared over a squared minus x squared over b squared equals 1. The center of the hyperbola is at the origin, then the transverse axis is on y-axis since the variable on top of a is y. For letter C, if you have an equation like this, the h and k were given, so therefore the center of the hyperbola h is at h and k, then the transverse axis is parallel to x-axis. Then for letter D, if you have an equation like this, the h and k were given, then the center of the hyperbola h is at h and k, then the transverse axis is parallel to y-axis. Solving equation of the hyperbola centered at the origin, let a less than c, b less than c, where c squared equals a squared plus b squared. I have here a table of the two equations that the center of the hyperbola is at the origin, since the h and k values are not given. So if you have an equation x squared over a squared minus y squared over b squared equals 1, to find the center, vertices, foci, co-vertices, and then the equation of the asymptotes, just follow the pattern below. If you have an equation y squared over a squared minus x squared over b squared equals 1, just follow the pattern how to find the center, vertices, foci, co-vertices, and then the equation of the asymptotes. Example number 1. We have an equation x squared over 4 minus y squared over 9 equals 1. The question is, locate the center, vertices, co-vertices, foci, and then the equation of the asymptotes, then graph. Solution: find the value of a, b, and c first using the formula c squared equals a squared plus b squared. So we have a squared is 4, so to find a, we have 2. Our b squared is 9, so to find b, we have 3. Then to find c, just substitute the value of your a and b, so we have c equals c 3.61. Then make a table for the center, vertices, foci, co-vertices, and then the equation of the asymptotes. After looking the values, let's graph. The center is at 0, 0, which is the origin. And then the vertices, foci, co-vertices, and then before we plot our line of the asymptote, we will use central rectangle so that we can plot the asymptote properly, because the line of the asymptote will just pass through the edges of the central rectangle like this, in this one. And the light blue color, the curved one, is one of the branches, and the other one is one of the branches. So this is now the graph of your hyperbola. Then let's name the line of the asymptotes. We have here this line, y equals 3 over 2x, and the other one is y equals negative 3 over 2x. As you can see, the graph of the hyperbola opens to the left and to the right because the vertices lie on the x-axis. Now let's have an example number 2. Our example number 2 is y squared over 16 minus x squared over 9 equals 1. So the question is, locate the center, vertices, co-vertices, foci, and then the equation of the asymptotes, then graph. Solution: find first the value of a, b, and c using this formula, and we all know that a squared equals 16, so to find a, we have 4. Then b squared equals 9, so b is 3. Then substitute the value of your a and b, so we have c equals square root of 16 plus 9, therefore c equals 5. Then after that, make a table for the center, vertices, foci, co-vertices, and then the equation of the asymptotes. After looking for the values of this part of the hyperbola, then let's graph this one using the Cartesian coordinate plane. We have the center at the origin, the vertices, the foci, co-vertices. Then using the central rectangle, plot our equation of the asymptotes. Then put the branches and then name this asymptote as y equals 4 over 3x, and the other one is y equals negative 4 over 3x. Then, as you can see, the branches of the hyperbola opens up and down because the vertices lie on the y-axis. Now let's proceed to example number 3. The question is, find the standard equation of the hyperbola and the equation of the asymptote centered at the origin if the foci is square root of 29, 0, and the vertices is 2, 0, negative 2, 0 are given respectively, then graph. Solution using this formula, and given are a, which is 2, b is not a given, c is square root of 29. Then look for our b using the formula, so we have Square root of 29 squared equals 2 squared plus b squared. So we have b squared equals 29 minus 4. Therefore, b is 5. Then, to find the equation of the hyperbola in the standard form, we will use this equation. We use this equation since the center of the hyperbola is at the origin and the vertices lie on the x-axis. Therefore, we will use this formula since the value on top of a should be x. So, then substitute the value of your a and b. We have x squared over 2a minus y squared over b squared equals 1. Therefore, the equation of the hyperbola in standard form, we have x squared over 4 minus y squared over 25 equals 1. Then, we will find the center, vertices, foci, and then co-vertices as well as the equation of the asymptotes so that we could graph this equation. So, we have here the equation x squared over 4 minus y squared over 25 equals 1. So, this is the center, the vertices, foci, co-vertices, and this is the equation of the asymptotes. After looking the values, using the Cartesian coordinate plane, we will plot this value. So we have the center at the origin 0, 0, vertices, foci, co-vertices, and then we will use the central rectangle so that we can plot the line of the asymptote properly. Then the branches, it opens to the left and to the right since the variable on top of a is x. Then let's name this line as y equals 5 over 2x and the other one is y equals negative 5 over 2x. Okay, let's proceed of solving equation of the hyperbola centered not at the origin. I have a table of two equations that will say that the center of the hyperbola is not at the origin if the values of your h and k were given. So, if we have an equation, the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared equals 1. To find the center, vertices, foci, co-vertices, and the equation of the asymptotes, just follow the pattern below as well as the other equation. So, let's have an example number 4. Our example number 4, we have the quantity of y minus 2 squared over 16 minus the quantity of x minus 3 squared over 9 equals 1. The question is locate the center, vertices, co-vertices, foci, and then the equation of the asymptotes, then graph. Solution, find the value of a, b, and c first using the formula. We all know that a squared is just equals to 16, so a is 4, then b squared is 9, so b is 3. Then substitute the value, we have c equals square root of 16 plus 9, therefore c is 5. Then, center is at h and k. So how to find the value of h and k? Using the formula, we have y minus 2 equals 0 and then x minus 3 equals 0. Therefore, y or k is 2, x is 3 or our h. Then, make a table. The center is at hk, so 3, 2. Then the vertices, we have the foci, we have the co-vertices, and then the equation of the asymptote. Then using the Cartesian coordinate plane, we will graph these values. We have here the center, the vertices, the foci, then the co-vertices using the central rectangle. Then we will plot our asymptotes. Then this is our branches, opens up and down. Name this line, we have y equals 4 over 3 times the quantity of x minus 3 plus 2. Then the other one is y equals negative 4 over 3 times the quantity of x minus 3 plus 2. Okay. Next, let's proceed to example number 5. Our example number 5 is a real-life problem. So we have, the question is, the hyperbolic representation of a tower shown below can be modeled by an equation x squared over 16 minus y squared over 125 equals 1. Find the width of the tower at the narrowest point in the middle and at the top of the tower. The height of the tower is given, which is 220 meters. Then, we will use this equation as the values of A and B because the tower is modeled in the equation x squared over 16 minus y squared over 225 equals 1. Then let's find first the value of A and B so that we can find the width of the narrowest point in the middle. So our A squared is equals to 16. So to find A is 4 and B squared is equals to 225.
B is equal to 15.
Then the vertices is 40 and negative 40. Then we all know that the center of this tower is at the origin since H and K were not given. So this is the origin at 0, 0, and then the vertices is 40 and negative 40. We all know that the transverse axis lie on the x-axis. Therefore, to find the width of the tower at the narrowest point in the middle, using the transverse axis length, we have 2a. So our a is 4, therefore 2 times 4 is 8. Thus, the width of the narrowest point in the middle of the tower is 8 meters. Then, to find the width at the top of the tower, we need to find the half of the height of the tower. So, since the height of the tower is 220 meters, half of this is the value of your y. So, therefore, we could have this value negative x and negative 110 and x, and we have 110 as the value of your y. So therefore, substitute the value of your y to the equation. The value of our y is 110 meters. So we have x squared over 16 minus 110 squared over 225 equals 1. Then we have the width at the top of the tower is approximately
59.22 meters.
So that's it. That's our discussion on hyperbola. This time, let us have some exercises. These are our exercises. Letter A. Determine the vertices, foci, co-vertices, and the equation of the asymptotes, then graph the following. Letter B. Write equation of hyperbolas in standard form. Then letter C. Solve the following. You can try answering these exercises at home. Now, let's evaluate if we have attained our objectives.
These are our objectives. Number 1. Locate hyperbolas vertices, center, foci, co-vertices, and asymptotes. Number 2. Write an equation of hyperbolas in standard form. Number 3. Graph hyperbolas centered at the origin. Number 4. Graph hyperbolas not centered at the origin. And number 5. Solve applied problems involving hyperbolas.
We have successfully attained our objectives. No one is perfect, but a constant practice leads to mastery. Thank you for listening, and God bless us all. Bye.